Hello, this is Mr. Messerman with the Chemistry of Earth, vodcast number 1. I can present evidence for the existence of atomic and subatomic particles. So we're going to talk a little about the atom, the concept of which comes from this mean guy, Democritus, from ancient Greece, who first put together the theory of the atom as an indivisible particle. Now we're going to jump up thousands of years, really, to the 1800s and John Dalton's atomic theory. Basically, the atomic theory says that matter exists as tiny, discrete particles, or units that we call atoms. What Dalton and his contemporaries saw that was when elements react, they do so in whole number proportions. Certain whole numbers of oxygen will react with carbon to make carbon dioxide and carbon monoxide, for example. So how could they do this if they weren't tiny, individual, discrete particles of their own type that make up the matter that is reacting in these reactions? They have to be discrete little particles of their own kind. We call elements, and elements are made of their own kinds of atoms. Alright, let's jump up to the later 1800s with J.J. Thomson's cathode ray tube. It's basically a primitive TV tube, here with an iron cross projected on one side. And what he found was there was rays coming from a metal electrode in this tube when he applied a voltage, electricity. And those rays were coming from the metal atoms. They had a negative charge, and he called them electrons. And electrons had to be part of the atoms. What else is in the atom? Well, these three scientists around the turn of the century, Ernest Rutherford on the left, Hans Geiger in the middle, and Thomas Marsden on the right, created this gold foil experiment where they bombarded gold with radiation. Most of the radiation went right through the gold and ended up on the screen with some deflection, but occasionally, as you see where I circled, some of them deflected right back towards the source. What this means is that there has to be a very tiny positive charge. The radiation they were using was positive, and it was deflecting the radiation backwards, and that's called the nucleus. So how does this all fit together? Well, that kind of belongs to Niels Bohr with his modern model and our current model of the atom with its little nucleus in the center and its electrons in energy levels or shells around that nucleus. He knew they were in shells because of the atomic spectra given off by different elements. There's only certain colors that go with certain energy jumps, energy levels, and energy transitions in the atom. And we have to go all the way to 1932 with James Chadwick for the discovery of the final part of the atom, the neutron. You can ask me what that picture is. So here it is. Here's an atom with its little nucleus in the middle, protons and neutrons, surrounded by a cloud of electrons. A couple other players in this process were Margaret Todd and Marie Curie. Margaret Todd coined the term isotope for different kinds of atoms, each with their own number of neutrons. And Marie Curie, of course, is famous for her work with radioactivity, which allowed Rutherford to do his work. She won 2 Nobel Prizes for this work. Thank you so much for watching. You're such a good student.